Greetings students, welcome to another lesson from iCampSA. Today we're going to be doing grade 10 mathematics, and we're going to be answering some questions from November 2025 exam paper, in particular geometry and trigonometry, and if the time allows we'll also get into some functions from paper 1 as we are preparing for 2026 June examination. Okay, without wasting any more time, let us get started. Okay, so we do have question 3 here, which is from 2026, and in this question 3 we are given a trapezium of QHFS such that QH is parallel. QH, we are being told that QH is parallel to SF. So one thing that we know about parallel lines is that the gradients of parallel lines, meaning MSF, the gradient of MSF is equal to the gradient of MQH. So that is that. That is another clue, So it's very important when you approach these exam questions that whenever you see something that you are familiar with or something that to just write it out, because you might actually need it when it's come to answering the question. So for 3.1.1, we are asked to determine the gradient of SF, and we are given those two coordinates of S and the coordinate of F. So for 3.1.1, we are asked to determine the gradient, and you know that in order to determine the gradient is the difference of the height over the run. So the gradient of SF is the difference of the height, so it's y2 minus y1 over the run, x2 minus x1. Okay, and then let's come here to our coordinates. For coordinate F, we have 3 and 0, and for coordinate S, we have 0 and -1. So y2, let's take the one for F, which is 0 minus -1 over the x coordinates is 3 minus 0. So it's 3 minus 0, of which would be equal to negative times negative is positive 1, so it's going to be 1 over 3. That is your gradient. Okay, and then for 3.1.2, we are asked to determine the equation of QH, and then as we've already mentioned that the gradients of these two lines, if they are parallel, the gradients are equal. So therefore we already have the gradient, and QH is a straight line. So let's go ahead and plug this into our straight line equation. For 3.1.2, the gradient of QH, we say it is equal to the gradient of SF, therefore equal to 1 over 3, and the straight line equation is y is equal to mx plus c. Okay, so we'll have to take now one of the coordinates there on the line QH. So we'll take coordinate H, since we have both the x and the y coordinate, so that we can solve for C. And remember that C is your y-intercept, but we'll get into that. Let's now plug in our values. So our y is 4 is equal to the gradient is 1 over 3 times 4 plus C. Let's quickly confirm, yes, those are the coordinates. Okay, so therefore we're going to have 4 minus 4 over 3 is equal to C. C is our y-intercept. C is a y-intercept. So 4 minus 4 over 3, for that is equal to 8 over 3. We'll just keep it as a fraction, 8 over 3. So that is your C, but we are looking for the equation of QH. Therefore the equation will be y is equal to 1 over 3 x plus 8 over 3. And remember, I told you that the C value is the value of the y-intercept. Now here we can see that the y-intercept is 8 over 3, and it is positive. So let's quickly confirm. So y over 3 when we change it to decimal is like 2.67, and here we have that y-intercept. It's positive, it's on the positive y values, and it's between that 2 and 4. Okay, so it makes sense. And then next we're asked to calculate the value of k. Remember, k is the x value of q, and q lies on the straight line, which is qh. So we have k, where q is at k, the y value is 2. Okay, so we have k and 2 coordinates. So let's go ahead and calculate that for 3.1.3, sorry, y, this is the straight line equation, x plus 8 over 3. So let's take the y value, which is 2. 2 is equal to 1 over 3. The x value is k plus 8 over 3. Okay, now let's simply solve for k. So we take the 8 over 3 to the other side. It's going to be 8 over 3. Negative 8 over 3 is equal to 1 over 3k. Okay, and then we're going to do the sum there. Let me punch it on the calculator. 2 minus 8 over 3 is equal to 2 minus 8 over 3 is equal to negative 2 over 3 multiplied by 3. We get negative 2. Therefore, k is equal to negative 2. K is equal to negative 2. Okay, now let's come here and see if it makes sense. So k is in the negative side of the x-axis, so it does make sense. Okay, and then from there we're asked to determine the length of hf. So hf, they are referring to this line that we have here, the line hf, and we're asked to calculate that length of that line hf. The length of the line hf, we have to use the distance formula, since this is a it's not a vertical or a horizontal, but it's a sort of a diagonal or a sloping line, so we'll have to use the distance formula. Okay, it's 3.1.4. we'll have to use the distance formula, 3.1.4. and then for line hf, it's gonna be hf, the length we are looking for, squared, is equal to x1 minus x2 squared plus y1 minus y2 squared. You can put it in the other way. You can start with x2 minus x1, but we are referring to the coordinates of h and the coordinates of f. So the coordinates of h is 4 and 4, and the coordinates of f is 3 and 0. So let's go ahead and plug that. We're gonna have 3 minus 4 squared plus 0 minus 4 squared. Okay, hf squared, let's bring this down, hf again, it's gonna be let's just say hf squared, the length we are looking for. So we're gonna have 3 minus 4 is negative 1 squared, is gonna be 1 plus 4 squared is 16. We introduce the square roots on both sides to remove that power 2 there on hf, and therefore hf will be equal to square roots of 17. That's the square roots of 17 units. You can leave your answer like this, or you can change it to the decimals. It's okay. Okay, so that is your 3.1.4. and then from there we also calculate the coordinates of m, the midpoint of hs, So right now we are being asked to utilize the midpoint formula. So a midpoint formula, so we have that line hs that joins the two coordinate h and s, and then at some point there will be a middle point, that bisects the line or that divides the line to two equal parts. And then there is a formula that you can use to calculate the coordinates of that midpoint. And then the formula of midpoint, I'll just say MP. It is equal to, for x is x1 plus x2 divided by 2 maps with the y1 plus y2 divided by 2. That is your midpoint formula. This one would give us the coordinates of M, the coordinates of M. So let's go ahead and do that. The H coordinates is 4 and 4, and then the S coordinates is 0 and -1, 0 and -1. Okay, this is 3.1.5. 3.1.5. We are asked to calculate the midpoint M of HS. I'll just say, okay, now it looks like a gradient. So let me just say MP, or let me just say M, since we're calculating the coordinates. I said it's going to be x1 plus x2 divided by 2 maps with y1 plus y2 divided by 2. That will be our midpoint. So this is essentially equal to the coordinates of S is 0 and -1. So it's gonna be 0 plus the coordinates of H is 4 and 4. So 0 plus 4 divided by 2, and then the Y values, we have -1 and 4. -1 plus 4 divided by 2 divided by 2. Therefore, the coordinates of the midpoint will be 0 plus 4 is 4 divided by 2. That will be 2. That will be 2. And -1 plus 4 is going to be 3 divided by 2. So those are the coordinates of the midpoint. They are both positive. Now let's confirm if they lie on the first quadrant, because they will be both positive in the first quadrant. And indeed, that the midpoint M of HS is found in the first quadrant. Okay, and then from there we are told for 3.2 line segment AB is perpendicular to the segment CD. Let's just see. Okay, now we're just told that we are no longer referring to the diagram here. We are just told about these two lines of which they are perpendicular. So we have line, let's try to draw a sketch. We'll say line AB is perpendicular to segment CD. Let us see segment CD and segment CD. Okay, so since segment CD is have that gradient of 2, that means it's the one with the positive gradient. So we're gonna have with red, we are trying to just sketch what we are being told here. This is segment CD, and then we have the line AB, which is perpendicular to segment CD. If they are perpendicular, remember that perpendicular lines, the product of the gradients of perpendicular lines is equal to -1. So we'll call that other one segment AB. These two lines, just arbitrarily. Okay, so line segment AB is perpendicular to segment CD. Okay, and then A, we are told that A is -5 and 2, so it lies in the third quadrant. A is -5 and 2, -5 and 2. Okay, and then B is P and -1, so B is P and -1 points on AB. Okay, if the gradient of segment CD, so MCD is equal to 2. Calculate the value of P. So what we have to do here is we essentially have to find the straight line equation of the line AB, and then we can solve for P once we have the equation. And then since we know that these two lines are perpendicular, we can use that equation I was referring to, that for perpendicular lines, the gradients let's say MAB times MCB or MCD is equal to -1. That's an equation, or it's a rule. It's a rule that the product of the gradients of perpendicular lines is equal to -1. Is equal to -1. Okay, and then from there, yes, so let's calculate the gradient of what? Of AB, and then we can solve for P. We are already given the gradient of CD, which is 2. Okay, now let's come here. This is 3.2. So MCD times MAB is equal to -1. We are given the gradient of MCD, which is 2 times MAB is equal to -1. Therefore, we divide by 2 on both sides. MAB will be equal to -1 over 2. -1 over 2. That's the gradient. And therefore, since we know that AB is a straight line, we can use the straight line equation, of which will be y is equal to mx plus cm for the gradient. And then let's check if we have a coordinate that lies on AB. And there we have it, the coordinate, which is A, that lies on the line AB. Is -5 and 2. Let's solve for the intersection, or for the y-intercept. So we have -5 and 2. Therefore, we have 2 is equal to m is -1 over 2 times 5 plus c. Therefore, c will be equal to 2 plus 5 over 2 is going to be 2 plus 5 over 2. 5 over 2 is equal to 9 over 2. Therefore, c is equal to 9 over 2, of which will now make the equation for the straight line AB, which is y is equal to mx plus c. It will now become y is equal to the gradient -1 over 2x plus 9 over 2. That's the equation of the line AB. Now, we have another coordinate B that lies on that line, which is P, the point B with the coordinates P and -1. P for x and then -1 for y. Let's solve for that. Let's substitute. -1 is equal to -1 over 2 times P plus 9 over 2. Let's go ahead and solve for P. -1 minus 9 over 2 is equal to -1 over 2 times P, and therefore -1 minus 9 over 2, 9 over 2 minus 1 is minus 11 over 2. It's minus 11 over 2 multiplied by a -2 is gonna be just 11. So P is just gonna be 11. Is gonna be, or maybe let me also include these steps. It's gonna be 11 over 2 is equal to negative P over 2. We multiply by 2 on both sides. We're gonna have P, the negative and the negative will cancel, so P will just be equal to 11. Okay, so there you have it. Just to highlight a few important things: the gradients of two perpendicular lines. Let me put the words there. Gradients of two, or yes, let's just put of two perpendicular lines. That is what we use to answer this question. That's the gradient of two perpendicular lines. Here is the midpoint formula. This is the midpoint formula. This is the midpoint formula we use to find those coordinates. And then here we have the distance formula. This one what I'm referring to. This is the distance formula that we utilized to answer that question. Distance formula. That's the distance formula, and then therefore straight line equation. And then here you have the gradient formula. This is the gradient formula. This is a gradient formula. So there you have it, guys. That is how you go about answering those questions. Yes, please make sure to subscribe on our YouTube channel, and also for these notes you can check us out on TikTok. These notes will also be posted there, and then they can be provided upon request from our official number for iCampSA. Have a wonderful day further, and also good luck with your upcoming test or exam. See you on the next video. Cheers.